In this video, I would like to show you how you can use a cube in order to demonstrate linear, quadratic, and cubic relationships. This cube has a length which we'll call x. And let's begin by looking at the number of vertices of the cube. The cube has 4 vertices on the top and 4 on the bottom for a total of 8. And no matter what the length of the cube, it will always have 8 vertices. So there's no variation in the number of vertices with the length of the cube. Now let's look at the total edge length. There's 4 edges on the top, 4 edges on the bottom, and 4 on the sides. That's 12. So the total edge length would equal 12 times the length of one edge. And we can copy that down to get that relation. That's a linear relationship. Now let's look at the surface area. Each face has a surface area of x squared, and there are 6 faces, so we get 6 times the edge length squared. And let's copy that down. So that's an example of a cubic relationship. And finally, the volume. The volume is simply equal to the edge length cubed. And so we have a zero-order relationship. There's no variation in the vertices with edge length. A first-order or linear relationship, a second-order or quadratic relationship for the surface area, and a third-order or cubic relationship. And these are the 4 relationships. Y, the number of vertices, is simple at 8. It does not depend on the edge length. The total edge length is 12 times x. The total surface area is 6 times x squared, and the volume is x cubed. And we can make a graph of this, and this is the graph, the y variable. The number of vertices is 8, no matter how large the cube length is. The total edge length is a linear function of the edge length. That's a relationship there. The surface area is a quadratic relationship, and that's a relationship there. And the volume is a cubic relationship. So this is a nice analogy that you can use to give students a feel for linear, quadratic, and cubic relationships. I used to use this when I was teaching kinetics to help students understand first order, zero order, first order, second order, and third order chemical reactions, where the rate of reaction depends on, could be either independent of the concentration of the reactant or linear in the concentration of the reactant, or cubic relationship, or a quadratic or a cubic relationship. So I hope this is helpful to you when you discuss mathematics in your classes or kinetics, whatever the case may be. Thank you for your attention, and I'll see you next time.